Welcome students from Spark Academy to chemistry classes. We learn so many topics regarding inorganic and few organic also. Today we are going to discuss one more topic from inorganic chemistry, that is hydrogen. Hydrogen and its compounds. For hydrogen its compounds weightage. So hydrogen its compound for first Eamcet. One question, one question from hydrogen's isotopes and water purification. Last one, hydrogen compounds like water and H2O2, hydrogen peroxide. Okay, hydrogen peroxide. Clear? So hydrogen and hydrogen peroxide, in that subtopics we expect the question for Eamcet. Now come to the JEE Mains and NEET. For JEE Mains NEET also the one question. So for JEE Mains NEET also the question first we give the more important from that subtopic is oxidation reduction property of the H2O2. So H2O2 oxidation reduction property, in that possible question. Yes, students, see this is my coupon ACI and 10. Use the coupon and listen the free lecture and get the tricks. So first, say the hydrogen. This is the symbol of the hydrogen. Hydrogen atomic number is 1. So what is the electronic configuration of the hydrogen? Hydrogen electronic configuration is 1s1. It has only one orbital. number also 1, mass number also 1. So atomic number here gives information for us about the electron or proton, but no neutron in the case of the hydrogen atom. So its atomic number is 1, and what about mass number? Its mass number also 1. So what is the atomicity of the hydrogen? Hydrogen can exist by this way? No, because hydrogen's atomicity is 2. It is diatomic molecule like 17th group elements. The hydrogen also exists H2. So its atomicity how much? 2. Only 2 atoms present in. And what is the type of bond present in 2 hydrogens? In the case of this hydrogen molecule, so here molecule means indicating it is a covalent molecule. So it has the which bond? Covalent bond between hydrogen. And hydrogen physical state. Hydrogen physical state is gaseous state. Now see hydrogen position. Yes, this is the structure of the periodic table. So in periodic table, hydrogen is located extremely left side, but it not included in the first group and not in the second group also. Why? Because hydrogen first has the similarities with alkyl metals. Same time, okay, it has similarities with the 17th group elements also. So we say here hydrogen has similarities with metals like alkyl metals. And what about non-metals? With non-metals, 17th group elements. So these are the 17th group elements: fluorine, chlorine, bromine, iodine. So this is the first group elements. They are called alkyl metals. So what are alkyl metals? So in that alkyl metals, the first one is which one? Lithium, sodium, potassium, rubidium, cesium, francium. So here hydrogen has the similarities with both. So can we say hydrogen can place the metal side and non-metals like 17th group elements? No, because same time it has what? Dissimilarities with alkyl, with metals and non-metals. So the hydrogen place is unique. Hydrogen place is unique in the periodic table. It is neither metal, neither like alkyl metal, nor okay these 17th group elements halogens. So after seeing the position of the hydrogen, now we check what are the similarities with alkyl metals and what are the similarities with halogens of the hydrogen. First see what are the similarities with alkyl metals. First we see the alkyl metals. So alkyl metals electronic configuration. So we take the first one is EC. EC stands for electronic configuration. So what is the general electronic configuration of the alkyl metals? Alkyl metals general electronic configuration is NS1. So they have only valency electron 1. If you take first one or any one, like so take sodium, sodium atomic number is 11, electronic configuration is 1s2, 2s2, 2p6, and whatever the last one, 3s1, 3s1. See here, so one electron present outermost orbit of the sodium. So here general electronic configuration of the alkyl metals NS1. Then what about hydrogen? Hydrogen atomic number 1. So what about electronic configuration? 1s1. So if see in the case of the electronic configuration, hydrogen resembles to alkyl metals. First, it is the first similarity. S. Next, these halogens, these alkyl metals, they have oxidation state is positive, because metals, they are losing electrons and they get what? They are getting positive oxidation state. So what is the oxidation state of the alkyl metals? Alkyl metals oxidation state is 1, S1 plus 1. So what about the hydrogen? Like alkali metals, hydrogen also, when alkali metals they combines with halogen X, so Mx, then M's means here alkali metal, its oxidation state is +1, then halogen is -1. Same this metal, okay, instead of metal, if I take the HX, H is what here? Hydrogen. So X is halogen. Then what is the oxidation state of the hydrogen here? So hydrogen oxidation state here +1. Then we can say in the case of the oxidation state, hydrogen resembles to alkali metals. Now, next, affinity of the alkali metals. Yeah, what is the affinity of the alkali metals? Alkali metals, they have affinity. Alkali metals, they have affinity towards halogens, because what are the more electropositive elements in the periodic table? In the periodic table, more electropositive elements are alkali metals. So like alkali metals, they have affinity towards halogens. Halogens are more electronegative elements in the periodic table. So same way, hydrogen also, see I take the M, affinity towards X. Same H also has affinity towards the X. Then in the case of the affinity also, hydrogen resembles to alkali metals. Clear? So these are the similarities with alkali metals of halogen, of hydrogen with respect to halogen. Clear? Now we see the next with halogens. Yes. Now hydrogen has similarities with same time the 17th group elements also. As so what is the outermost electrons of the halogens? 7. For them required only one electron to get the stable. Getting one electron for every halogen becomes what? Stable. So same way for hydrogen also required one electron to get stable. So in the case of the getting stability, hydrogen resembles to the halogens. So what is the in the case of the first one? First one is getting stability. Means next second one. Second one, what is the second one? See, second one, if we see, check the second one. What is the ionization potential of the halogens? So halogens, okay, due to having the more electronegativity character, their ionization potential is high. Their ionization potential in thousands, like 1100 as 1000 above. So what about the hydrogen? So hydrogen in the case of the ionization potential, it resembles to halogens. How the hydrogen, how the halogens, they have in thousands ionization potential. Same here hydrogen also having the 1210, okay, kilocalories or kilojoules ionization potential. So then we say in the case of the ionization potential, so hydrogen like halogens. So these are the similarities. Same time it showing dissimilarities also. Same time it showing what? Okay, dissimilarities with halogens and hydrogens. So we say hydrogen place is, okay, not in the correct place, the side of the alkali metals, not in the correct side of the what? Alkali metals. So see here, so similarity, what about in the case of the first one? Okay, the flame, okay, flammable in the case. Next one, oxidation state. Next one, reaction with water. Next one, okay, non-bonding metals. Next one, yes, outer shell electronic configuration. So in the case of the these, hydrogen showing similarities with alkali metals, same time showing similarities with halogens, but same time it has the dissimilarities also. So that's why the place of the hydrogen is separately in periodic table. Yes, after learning the position and the similarities, dissimilarities of the hydrogen, now we check the isotopes of the hydrogen. Yes, hydrogen has three isotopes. So what is the definition of the isotopes? Chemical species having same atomic number. So atomic number is same, 1, 1, 1. But they are having what? Mass number is different. Yes. So what is the mass number in the case of the first one? 1. What is the mass number in the case of the second one? 2. What is the mass number in the case of the third one? 3. Yes. So by this way, hydrogen has 3 isotopes. What are they? In that first one. So first one is called, yes, first one is protium. It is the first isotope of the hydrogen. Second one, deuterium. It is called heavy hydrogen. So third one is tritium, otherwise radioactive. Why? It has the off life. So chemical species which are radioactive nature, they are having what? Off life. So off life nothing but T off. So chemical species which have the radioactive in nature, they contain what here? Off life. So here tritium has off life. So this indicating tritium is what? Radioactive element. Clear? Now see the protium, deuterium, tritium. These three are isotopes of the hydrogen. Now we check the first one, protium. Atomic number 1, mass number 1. Deuterium, atomic number 1, mass number is 2. So number of here proton electrons 1. What about number of neutrons? 0. What about in the case of the deuterium? Number of protons and electrons 1. What about here neutrons? Neutrons also 1. Then 1 plus 1, 2. Now what about here? 2. 2 plus 1, 3. Yes. So this is protium, deuterium, tritium. So here protium, it is called protium, present 99.984 percentage. What about the deuterium? 0.0156 percentage. So what about the tritium? Tritium is okay, radioactive, means it has what? Off life. It has off life. Now we see some compounds of the hydrogen. Hydrogen has two types of very important compounds. In that first one is what? Water. It is called hydrogen oxide. Second one what here? Deuterium oxide. Third one here, okay, tritium oxide. But these are in that the first one is H2O is very important compound of the hydrogen compound. Now after the H2O, one more compound is H2O2. H2O2 is called hydrogen peroxide. So what is H2O2? H2O2 is called hydrogen peroxide. Clear? So hydrogen peroxide. Now we see the properties of the water, heavy water and super heavy water. Water is H2O. Heavy water is D2O. And what about the super heavy water is P2O. Yes. So molecular weight and next melting point, boiling point, texture of the maximum density. Maximum density is more for, it is tritium. Next maximum density as they given, and vapor pressure also more for water only. Now viscosity also more for, not water, more for, it is deuterium oxide, heavy water. Is clear? So next enthalpy of formation. Next enthalpy of vaporization, because they are liquids, they have what? Enthalpy of vaporization. So enthalpy of formation, enthalpy of vaporization. Clear? Enthalpy of formation, enthalpy of vaporization. Yes. So after learning the H2O2, H2O2 is called, H2O is called what? Water. Yes. H2O is called water, hydrogen of the oxide. Yes, just now I said. Now, okay, next compound of the water. What is the next compound? So next compound of the water is H2O2, hydrogen peroxide. So what is the formula of the H2O2? So H2O2 formula. H2O2 formula. So H2O2 only, the formula of the H2O2. Actually H2O2 is called hydrogen peroxide. So why it is peroxide? Question number 1. So if we see the structure or formula of the SH2O2. So I write HOOH. So O nothing but here oxygen. In oxygen, what type of bond there? Generally, oxygen has double bond. So its valence is 2 and it is electronegative element. But here oxygen oxidation state is -1. So why it is -1? When oxygen present in the peroxy bond. So peroxy bond nothing but oxygen oxygen single bond. So when it is in the case of the oxygen oxygen single bond, its oxidation state is 1. So when oxygen oxidation state is 1, that bond is called peroxy bond. So this H2O2 is called hydrogen peroxide. Now, what is the main important role of the H2O2? H2O2 acts as a oxidizing agent and reducing agent. So, what is the meaning of oxidizing agent? So, what is the meaning of oxidation? Oxidation nothing but first one addition of oxygen. So, for any molecular atom you add the oxygen, that is called oxidation. Next, removal of electron. So removal of electron also called oxidation. Third one, increasing oxidation number. For example, oxidation number is +1, that became +3 or +2. So here oxidation number +1 to +3 +4 is increased, decreased, increased. So increasing oxidation number also called oxidation. So these are the what definitions of oxidation. What is the first one? Addition of oxygen, removal of electron, increasing oxidation number is called oxidation. Now see what is the first oxidation equation of the H2O2. H2O2 reacting or oxidizing the lead sulfide. So what is the formula of the lead sulfide? PbS. So lead sulfide, they are present in black color. So when treating with H2O2, after some time the black color of the lead sulfide becomes white. So due to the oxidation. So here which one underwent oxidation? PbS, lead sulfide. So with the help of H2O2. So what is the H2O2 role? Oxidizing agent. But it is easy if one molecule acts as the only oxidizing agent. But here H2O2 acts as a both oxidizing agent as well as what? Reducing agent. Then it is very difficult task to students to find out the exam, is it oxidizing agent or reducing agent. But I makes you here very clear how to find out the H2O2 is oxidizing agent and reducing agent in the question. Clear? Here first oxidized black lead sulfide to white. Here color is changed. So black color of the lead sulfide become what here? White. So here H2O2 role is very clear. It acted as a what? Oxidizing agent. And how to know by oxidation method? See, in oxidation method, yes, Pb, here oxidation number is same, but here number of oxygens increased in the case of the first reactant. Here how many oxygens there? 4. So it is very clear. So H2O2 acts as a oxidizing agent. Okay, clear. Now in the case of the second reaction also it is the oxidizing agent. Clear. NO2 minus H2O2. So NO2 here contain how many oxygens? 2 oxygens. So NO3 minus contain how many oxygens? 3. So increasing oxygen number also called oxidation. Next, reducing nature. See, so same time this H2O2 acts as a reduction agent also, means reducing agent. It makes other molecules to undergo what? Reduce. For example, here AgO, silver oxide. Silver oxide became here silver. And what is the role of H2O2? Reducing agent. But I said how to we conclude H2O2 acts as a reducing agent. Very clear. So what is that information? That information is yes, releasing of O2. Yes, when in reactants oxygen gas is liberates. So that is indicating the role of H2O2 is what? Reducing agent. So very clear. So in the case of the down reaction, which one? Chlorine with H2O2. So chlorine with H2O2 we got again here what? Oxygen. Clear. So it is clear what is the role of H2O2. So H2O2 role is, okay, reducing agent. Why it is reducing agent? Because here we got what? We got here, yes, we got here in the case of this reaction, okay, we got here what? We got S, we got here, okay, oxygen. So liberating in the oxygen sign, we say here, it acts as the what here? Reducing agent. So clear? So it acts as oxidizing agent and reducing agent. So it is our spark store. So many things available from our side. Long-term courses, crash courses, mock test, previous year solutions, study materials also for JEE mains, NEET, Eamcet, IIT Foundation. Short term, long term, both are available from our two branches, Narayanguda and Mehdipatnam. And apply my coupon here compulsory and see the free lectures. SCI 10S, it is my code, and daily and demand solutions also present every day. And our methodology. So after seeing all things, now we see, yes, examples from this chapter. Yes. So in that, what is the first one? Yes, in that first question is, one would expect proton have to have very large. Yes, what is the yes? First here we have to understand the question here. Okay, one would, okay, expect a proton to have very large. So what here proton having the large, is it charge? Otherwise ionization potential, otherwise hydration energy or radius. So we know the ionization potential of the hydrogen is high, but we are talking about the proton, yes, because it is very small size. Then what about its charge? Charge is common for hydrogen, otherwise hydrogen and hydrogen cation, that is clear. Next, what is the next one then? So radius is small because due to the small atomic size. So answer is hydration energy, because this particle has very small charge. Then its charge also and atomic size also very small. Due to that reason, when it dissolves, so then its solubility is decreases. Why? Because here hydration energy is more. Yes. So what is the answer? Hydration energy. So hydration energy of here proton very high. So that due to the hydrogen energy is high only, the remaining things all are small. What about radius? What about the charge? What about the ionization potential? Clear? So only what we have to see here, which is the large one. What is the large one here? Large one only hydration energy. Next question. The ionization of hydrogen atom would give rise to. Yes. So what it will give here? Okay. So ionization of hydrogen atom. So we take the hydrogen and we put in the ionization. Yes. It is undergoing what now? Ionization gives what? Yes. Okay. H minus. Okay. Yes or no? H plus. Then gives what? H plus mostly. So what is H plus? H plus is it hydride ion? No, because it has positive charge. Next, hydronium ion is called H3O plus. So what about the answer? Answer is proton. So H plus ion is called proton. So when this hydrogen ionizes, it gives H plus ions. So H plus ion is called proton. Clear? So what is the answer? Answer is C. Okay, proton is the answer. Yes, of after seeing the second example, now we can see the next, yes, third example. What is the third example? Which one of the following pairs of substances on reaction will not evolve H2? Yes. So what are the substances? They are not giving H2 gas with hydrogen. Yes. Okay, we see. So first one in that, yes, first one, what is the first one? First one is copper. Second one, iron steel. So yeah, iron steel both are, iron steel here both are, they are giving what? Yes, hydrogen gas. And sodium and ethyl alcohol also they produces iron and H2SO4. But copper, okay, and HCl, they won't evolve the H2. So what is the answer? Answer is copper and HCl. So copper and HCl is the correct options because the iron, and what about along with H2SO4 and ethyl alcohol, they are liberating hydrogen gas. But only in the case of the copper, copper has reduction potential value is positive. Okay, due to that reason here no evolve of H2 gas. Next question number 4. Yes. Water gas is produced by, yes, what is water gas? CO plus H2. So this is the combination of CO, carbon monoxide plus H2O. This gas is called water gas, syn gas, synthesis gas, producer gas, otherwise blue gas. So water gas, when it will come out, means when it will produce. So when it will produce, when passing, okay, steam through a red hot coke. Yes, what is the steam? Steam means it is the gaseous state of the water plus what about here red hot coke. Coke nothing but carbon. Yes, when the reaction between carbon and H2O result is, okay, what? Water gas. So water gas also called producer gas. So then what about the option B is wrong because here saturation is not gives the water gas. Next also, so the oxygen hydrogen the mixture that gives what here water only, but heating mixture of CO2 and CH4 also it is what not possible to give the water gas. So water gas possible passing steam through a red hot coke with carbon is a coke. Coke means it is symbol is carbon. Yes, the result is here water gas. So next question. Next question is, which of the following metal evolves hydrogen ion reacting with cold dilute HNO3s? As cold dilute HNO3s. So here aluminium, okay, reacts with normal water, and what about iron and copper also, but magnesium. So magnesium is electropositive metal. Yes. So see in the given list which is more electropositive metal. Generally in the periodic table the more electropositive metals are first group elements. But here in the given options first group element is not there. Then so after first group we have to consider the second group. So after first group the second group elements also more electropositive. So in the case of the second group elements, which example here given? Magnesium, because aluminium is 13th group element, iron copper they are from the D block elements, only magnesium only, that is second group element, it is more electropositive. So it reacts vigorously and evolves what? Hydrogen gas. Okay, so answer is here Mg. So we have to think the appropriate answer, that is what? Magnesium. Next question, sixth question. Which of the following statements about hydrogen incorrect? Now we read the one by one statement. First statement, what is hydronium ion? So what is the hydronium ion? H3O plus. It forms proton between water when the dative bond will form. So then we say the first option is, okay, correct option. It is not incorrect because in that hydronium ion exists freely in the solution. So it is what? Correct statement. Next, dihydrogen does not act as the reducing agent. So addition of hydrogen is called what? Reduction. So hydrogen, with the help of hydrogen, we do what? Reduction process, like hydrogenation of the oils. In that required hydrogen, so many organic metals they are undergoing what here? Reduction. Then we are using hydrogen is the common reducing agent. So dihydrogen does not act as a reducing agent is wrong, because itself it acts as a good reducing agent. So hydrogen has three isotopes from which tritium is most common. No, tritium is what? Radioactive element. First one, protium, deuterium, they are called common. So first one is very common. So then this is the incorrect statement. So hydrogen never acts as a cation in ionic salts. So in ionic salts, hydrogen acts as a what? Anion. So then, so we say yes. So some whenever whatever in the ionic salts. So in the case of the ionic salts, more ionic compound is what? More ionic metals are first and second group element. Then hydrogen is neither acts as a what here cation. There hydrogen role only -1 oxidation state. So this also correct. So then B and C both are incorrect statements here. Clear? So after this example, next example next one is, yes, after which one? Seventh one. Yes, this is seventh one. Which of the following is electron deficient? So here all are hydrogens there. So actually here hydrogen forms binary compounds. So when hydrogen with 13th group to 18th group up to 17th group, it forms the hydrides. So these hydrides they classified by what? Depends on their complete using of the valence electrons, and that they are divided into electron deficient, electron rich, electron precise hydrides. Now here, so which one is electron deficient hydride? So in the central atom of the hydride which does not complete octet rule, so that molecule is called electron deficient hydride. Now we check the C2H6. Here carbon valence is 4. Yes or no? So we take first C2H6. So in the carbon-carbon single bond, around 3 hydrogen bonds. Here carbon valence is fulfilled. Same in the case of the phosphorus also. Same in the case of the silicon also. Yes. So they contain what here? Octet electronic configuration. What about in the case of pH3? So here P has the 3 bonds but 2 electrons in at the phosphorus excess. So here also octet. Then we say first one is what one? B2H6. Yeah. We know the B2H6 is what? Diboron. So in that boron octet rule does not complete. So the first one is called electron deficient hydride. So answer is B2H6. Now next question. The method used to remove the temporary hardness of the water. Yes. So what is the method here? Yes. So see here the method used to remove the temporary hardness of the water. How we remove the temporary hardness of the water here? Yes, we can remove the temporary hardness water by Clark's method. Actually, water is two types: soft water, hard water. So soft water we know, but hard water again two types: temporary hard and what? Permanent hard. Here, due to the carbonates, we say that water is temporary hard water. That hardness we can remove by boiling. Clear? By boiling also we can remove the temporary hardness of the water. But here Clark's agent, so we are using calcium hydroxide. So calcium hydroxide is called what? Clark's agent. Okay, with the help of that also we prepare here what? Pure water. So what is this answer is Clark's method. Yes. So next question. The number of hydrogen bonded water molecules associated with copper. Yes, see question number 9. So question number 9, answer is here, okay, B. Only one water molecule only associated. Why? Because copper is what? Copper is D block element. Yes, it increases what it's, okay, yeah. So increases what it's, yes, yes, it increases what here? Coordination number. Then it extends up to 5. Then answer is B. B is, yeah, number of hydrogen bonded water molecules associated with the, okay, copper sulfate only one. Yes. Yes, next question. Which of the following groups of ions makes water hot? Yes. So what are the groups? Yes, that makes water hot. Sodium bicarbonate? Yes, no. So bicarbonate is calls for temporary hot water. Magnesium chloride? Yes. So what is the answer? The magnesium and chlorides. Actually calcium, magnesium, chlorides, sulfates, yes, they are responsible for make the water hot. So we say the which one? So answer is B. So B answer, yes, that is the correct answer. See, so by this way, yes, okay, we can expect from this subtopics clear. Yes, okay. So in this here we learned, yes, the introduction of the hydrogen and position of the hydrogen. Yes, and what about isotopes of the hydrogen properties? Next, the role of, okay, what, uh, hydrogen compounds like water and, okay, hydrogen peroxide. Clear? So water and hydrogen peroxide role is very important. It acts as a both, what, oxidizing agent and reducing agent. As clear? Yes. So here we have to see what the role of the H2O2. So H2O2 acts as a here what, oxidizing agent and reducing agent, that we have to remember. Next to the purification methods. So remain things we learn in our next topic, next class. So what about that purification of water? In that, what are the types of the water? Hard water, soft water, temporary hard water, and what about the permanent hot water? How do we purify? These all things we learn in our next YouTube class. Yes, thank you students, and see any doubts please. Anything is there you not understand? Thank you. There is a class.